Welcome back. Way back in episode 28, I did a video on how to convert one of these ATX power supplies into a benchtop supply for lab use, testing things out, whatnot. And it's actually become one of my most popular videos. And because of that, I get quite a bit of questions on it. So I figured I would do a follow-up video to try to answer some of those questions that I get and maybe clarify some things that I missed on in the original video. So I'm going to start this video off by showing you a little bit of a progression between what these things look like when they come out of the computer, what they look like once you slightly modify the wiring on it, and then what the potential could be once you actually have one finished off. And I'll also show you the one I have permanently mounted on my desk, as well as my flagship supply, I'll call it, something I kind of came up with, and it's been very, very useful for me. So we'll start with this guy here. Now this was ripped from an old Dell computer, and Dell is a little bit of an exception to the power supply game here, because you can see they kind of do things a little differently. They don't have all the wires coming out of one end, and they kind of, you know, make their cable lengths based upon the case you're using it in. And they actually used to use different color wiring, but at some point they went with the standard. This one here is one of the ones where it's not standard. You can see they actually used white where normally you'd use yellow. So we'll kind of just reference this to just being a completed supply. But for the rest of the video, we'll take a look at ones that are a little bit more standard, just to make it a little bit easier to look at. But what I did in episode 28 is I mentioned that you need to cut all these ends off and combine all the like colors together. And I went over the color codes and whatnot in the other video, but I will run through that really quickly in this one. So here's the supply with all the wires kind of clipped together. And if we look, the majority of the wires here are these black cables here. I'll just pull all of them together. These are your ground, or yeah, we'll call them ground because there is negative voltages here, and I don't want to get confusing, but these are your ground cables. Then we have your orange. Orange is positive 3.3 volts. Red is positive 5 volts. Yellow is positive 12 volts. Blue would be negative 12 volt. Sometimes there's a white wire that would be negative 5 volt. Then you have these three, what I'll call signal cables. The green wire is what's going to actually activate the power supply. You need to put a switch in between the black and the green in order to turn the supply on. You can also just touch the wires together and it will power up. The gray wire is what's called power good. This is the wire that would send signal back to your motherboard to tell the computer that the power supply is operating at the correct voltage. You can put an LED between that and the negative or the ground here in order to get that to light up to indicate that it's good instead of getting a signal, because this is after all a 5 volt signal. And then you also have this purple wire. Now this purple wire is the standby 5 volt rail. What I end up doing is putting a different color LED on that, between that and ground here. And I also put a USB plug on that, and that will allow me to get 5 volts as like a standby voltage. Now the way that whole thing works, when you plug this in, you get the mains voltage into this, and then that mains voltage gets stepped down to 5 volts on just that one individual little rail. And that 5 volts goes into the motherboard, and it's just enough power and current to allow you to turn the computer on. When you push that little power button in the front of your case, you're sending that signal. That signal's coming through to a switching circuit, if you will. And that switching circuit is just taking the green wire and the black wire and connecting them to the motherboard somehow. It's switching it on, and that's what allows this supply to come on to full voltage, which means the 5 volt, 3 volt, and 12 volt rails all come up. Your computer starts to boot, and at the same time, this senses all the voltages internally and then kicks back 5 volts to the motherboard to say, yep, everything's good. You can power yourself on and your computer boots. And all this happens in like a split second. I mean, it's really very quick that this happens. There's one wire I didn't cover, and that's this brown wire. That's your 3 volt sense cable. Now this actually I found tends to change color between devices. The best thing to do is when you take it apart, when you have your main connector here, look to see which of these wires is doubled up. So you can see this brown and this orange wire goes into one of these pins. That's because it's reading the voltage at that pin. So when you unclip this here, you might want to put something on this to keep these two wires together, so you know when you reassemble this, those wires have to go back into each other. The supply that's off to the very far side over here actually has a sense wire on the 5 volt and the 3.3 volt rails co-equally. So that's something you definitely have to make sure you do, because if that's not sensing the correct voltage, this won't work right. Not only that, but it won't put out that that power good signal. You can actually see this power supply over here. I have a couple switches. Let me get this wire out of the way here. The main switch over here turns the power supply on and off. This is what actually applies the 5 volts, I should say the mains voltage, to the standby. So that's what this red light is. It's telling me that mains voltage is coming in here, which also means that this USB port is active. When you flip this other switch right here, you can see the green light comes on, which means power good. The switch is obviously that connection between the green and black wires, and then the whole rest of the power supply comes up, hence why all these little LED readouts light up, and the lighting in the case here all lights up, because that is powered off the supply. If I shut the switch off, you can actually see everything died out, but we're still in standby mode. We are still getting 5 volts out of here. And then if I shut this off, we're not getting mains voltage in anymore, but the light's still lit. That's because there's that much energy stored on the capacitors in here. And I'll get into those in just a brief moment, but you can actually flip the switch on and you can see everything turn on for a brief second while there was still enough power in this thing to be able to actually flip everything on. And you can see now it actually went completely out. That's a good indicator to know that those capacitors don't have any kind of charge left on them either. So you can see, taking this supply, modifying, and then building it into a final project, or even better yet, one of these bench supplies like I built here, is definitely a very cool thing to do. Even the one I have over here, which powers my internet and everything like that, they're definitely very handy, but if you don't get the color coding right, you know, you can mess things up. And I mentioned capacitors. These all operate off of mains voltage. Depending on where you are in the world, it could be as low as 110 volts, it could be as high as 240 volts, or even higher, depending on, you know, how the sine wave works. Those caps store quite a bit of juice, not just voltage-wise, but just in joules. It's a lot, and if you touch it, you could potentially kill yourself, or at least hurt the hell out of yourself, give yourself a good burn in your hand, and it's definitely something you don't want to go messing around with if you don't know what you're doing. What I tend to do is, if I test these out, I'll let them just drain off on their own. You know, certainly within 10 minutes they're completely drained. So beyond that, you shouldn't have to have any kind of worry. But you can always go in and use a screwdriver and short them out. Now that's a good way to get the power off of there, but you got to be careful, because you do get sparking and stuff when you do that. But it's just like anything else. You know, if you don't know what you're doing, be very careful. You know. But I already took the screws off this. We'll get inside here and I can show you real quickly. Here are those caps. Obviously the connector's on the other end of it, so unless you take the circuit board out, it's not really too much of an issue. But you should just be wary of it. Also, if there's any exposed pins, now there should be protection where if you unplug the wire here, you shouldn't get a shock off the pins. I mean, that's just a common safety feature. But you can see here's all those wires, how they all just connect down to the motherboard. Now what they do is they actually crimp a little crimp on the end of all those wires, and there's a large enough hole that they just insert that in and solder from the back. If you desolder these, you'll find there's actually quite a large hole in there. What I do is actually, some of the supplies I built, I used a larger gauge cable. Instead of using 3 of these, I think they're 18 gauge, and this is what you need, by the way, these all together, and then the sense wire. You can actually put a terminal on the end of these, like I have over here, and get your 3.3 volts out of it. And this one here will put out somewhere over here 18 amps at 3.3 volts. So in order to get that full 18 amps, you're going to need a pretty beefy cable or multiple smaller cables, and that tends to seem a lot of people do. But when you do the larger wire, like you can see over here in the distance, it's definitely a lot better because you don't have so many smaller cables to be all bulky and everything. You just have larger ones. So it depends on what you're doing with it. Also, this one here is a permanently mounted one, so I used a slim power supply just so it didn't take up a lot of room on my desk. But I ran it over to a terminal strip, as you can see, and I can access any of these. So if I have a project that I need to power up a lot and just keep it running all the time, I can just screw it into these screw terminals here and just go with it like that. But what I actually did was a lot of these come out the other direction. So you can see there's some of these wires going down into this hole. This is just a little piece of wood just nailed to my desk here. But that's where I have the AC on, the power supply good. I'll pan over here. AC on, power supply good, and then the switch. So if I shut the switch off, this green light goes on, but the red one stays on just to let me know that the power supply is still receiving mains voltage. And I also have the 5-volt standby rail on here too, so if I wanted to, you know, power my cell phone charger or do anything like that, I can just do that with one of these connections. I also have one of these out in my shed like this because I have a fan out there and some LED lighting and stuff like that that's just more permanently mounted. Whereas the one on my bench over here, where I use it for testing circuits out and stuff, that has the banana plugs right on the front of it. In fact, this one I actually have the 12-volt brought out, the negative 12-volt on the blue connector over here, just because I just did it anyway. And then a lot of the questions I get is based on what colors or which, you know, the last question I got was, I have a white wire. What's the white wire mean? Because, well, in episode 28, the power supply I was working on didn't have a white wire. I find that the white wire is typically your negative 5-volt rail. Some of these power supplies, like this one here, is nice because they actually tell you the 3.3-volt rail puts out 28 amps, and it's the orange wire. So you can just follow this straight across and see what colors belong with which power supply. So if you look over the blue one, yep, that is negative 12-volt. White, yep, that's negative 5-volt. I don't have negative 12-volt or negative 5-volt brought out to the front here because at the time I didn't need it. But when we look inside here, you'll actually see what I did was I just looped them off and just put some heat shrink around it. So if I do need that for something, I do have the leads there. Also on this one, you can see there is a USB port, and that's just connected to the purple wires, as I mentioned before. And you can see there's actually a large heat shrinked piece of wire going down to the LEDs, and there's a little bit of a neater way to do this. This is, of course, my more primitive design. Nowadays, I just mount a little circuit board up here and then put all the resistors for the LEDs and everything like that right on the circuit board. But the rest of it's just brought down. There's some eye hooks on the end here. Obviously, you can only fit so many cables into one of those eye hooks, so there's probably 2 or sometimes 3 eye hooks all bundled together with one piece of heat shrink on it, just put in place. That's pretty much it. Now, some people ask me, well, what about these resistors? Sometimes I hear I need to put a resistor in here. Now, this is a 10 ohm, 10 watt power resistor. The point of the power resistor is to get voltage up to the proper voltage, basically. Sometimes these switch mode power supplies need some kind of a load in order to get them up to their proper voltage. And this one, when I put it together, I tested it out and found out that that was indeed the case. It ran at, let's say, 4.5 volts or 4.7 volts or whatever it was, and then once I put this resistor in line, it brought it up to the proper 5 volts. Now this is just hooked up between one of the 5-volt wires here and ground. That's it. What I also did was I built this little tester. Now this is 2 10 ohm 10 watt power resistors, and I call it a dummy load because this is essentially what it is. And they're hooked up independently from each other. So you can either hook it up one way and get, I think it's half the resistance but double the current, or something along those lines. The important thing is I did 2 of these because some supplies I found needed a 12-volt and a 5-volt resistor on it to pull both voltages up to the correct one. The large power supply up on my bench over here, that was not the case. So this one does not have a 5-volt regulator in it, or I should say a 5-volt power resistor. Some do, some don't. So I'm actually going to go ahead and pull out my multimeter here, and I'm going to show you what that does basically, and we'll do some measurements on it, and then that's pretty much going to be it for this, because there really isn't any more to put into this. Between episode 28, I explained quite a bit. That actually went through the whole process of cutting everything off, combining everything together. So if you want to see a more in-depth video, I would definitely go check out that one first, obviously. Or check that one out after this one, obviously, if you're watching this one first. And you can see kind of what the differences are. This supply, I actually did a few different builds on it, like building the faceplate and the internals of it. But I didn't actually do one video kind of opening it up and showing you what I did. So I do anticipate on doing that pretty soon. In fact, now that I have all these other power supplies out, maybe I can use that to power my lighting and everything here while this one's being disassembled. All right, what I did here was just took all the wires that I didn't need, got them out of the way, and they're all bundled up nice and neat like this. And I have basically one of every color represented out here. And I'm going to show you whether or not you need a power resistor or not in your particular circuit, and also some other things here. So first off, this is plugged in. Nothing's hooked up to it right now. The fan's not spinning, but I'm going to be very careful with this part of it because, like I said, there is mains voltage here, and I don't feel like dying today. So anyway, I have two alligator clips on the end of my multimeter over here. I'm going to take the black and connect it over here to the black wire for our ground. And first thing I'm going to do is I'm going to touch the purple wire over here. And you can see we have 5.7 volts. And again, that's our standby voltage. So this is where you want to hook up your USB to, or you want to hook up an LED to, so you know you are actually getting mains voltage in. No worries. If I touch the black wire here that's in the alligator clip and the green wire together, you may hear the fan kick in, and now that power supply is completely active. You can see we still have 5 volts there, obviously. I'm going to disconnect that. And let's go with the blue wire over here. You'll see we have negative 11.91 volts. So there's, again, it's a negative 12 volt power supply rail. If I disconnect that and go over to the yellow wire here, we get 11.89. If I go over here to red, we get 5.16. Now, based on that, we're pretty good. We don't really need to put a resistor on this because there's enough going on in this power supply right now where it's pulling it up to the correct voltage. If you put this on here and notice that you weren't getting the full 5 volts, well, that's a good indication that you need to put the power resistor in place. That's pretty much all there is to it. If I go over and put this on orange, it's 3.4 volts. Now that really should be 3.3 volts. So perhaps if I put the resistor on here, that might change that. But you will notice I don't actually have the sense wire connected to anything. It's kind of just floating off in the breeze here. So if we connect those together, the orange and the brown wire here, that doesn't really do anything to the voltage either, which is expected. But what that might actually do is it might not actually provide any kind of signal. It is providing a signal to the power supply good rail. You are seeing you're getting 4.9 volts out of it. So in this particular situation, the sense wire really isn't doing a whole lot for us, but it is always good to keep that together. As you can see, I do have it clipped together. Now we'll go back to that 3 volt rail here. Once I connect the sense cable in 3.3, we'll put this on. And then what I'll need to do is take the power resistor. I'll take one of these leads for the 5 volt. I'll connect it into this side over here. And now I'll need to take one of these ground wires out. I'll do a quick wire strip on this. And we'll see if I touch this in here, minding the other wire. Nothing. Didn't change anything. So to put a power resistor in this particular supply would be a moot point. There's no need for it. You're going to get pretty much close to that voltage anyway. All the leads do test out. So this particular one, I would say just save the couple bucks and don't even bother putting the power resistor in. A lot of the newer supplies seem like they don't need that. It's just the way it is. They're just more stable on their own. Perhaps they already have some kind of feedback system built in here to stabilize the voltage. This older supply over here, as I mentioned earlier, when I did test that out, I did not get consistent voltages. I needed to put the power resistor into place. That's fundamentally it. The only other question that I ever remember getting about these particular things, besides what color, besides the power resistor, is can I actually put some kind of a potentiometer on one of these leads to trim the voltage down? The answer is yes, you can, and that's not really an efficient way to do it in my opinion. What you're better off doing is getting yourself one of these buck converters. And this is actually a really handy device. You can see up top, this is your input, this is your output. Inside this device, this wire just connects to the backs of these terminals, and then I have my own terminals over here. And as you can see, I have it adjustable from 0 to 12 volt, 0 to 3 amp, and you would adjust that by moving these numbers over here. You hit this button to turn it on and off. This is actually on, this is off, but if you cycle off, you can go between amperage and voltage. And based upon the LEDs over here, if I turn this on, you'll see it went to constant current for a minute, and then it went up to constant voltage. This is definitely a much more efficient way to step the voltage down to whatever you want. Now, the one thing about this is it's only going to go as high as the input voltage, which is only 11.6 volts. If you mess around with these a little bit more, you could probably get a little bit of a higher voltage coming out of this thing, so you do have a higher starting voltage. The other thing you can do is, instead of a buck converter, which bucks the voltage down, you can get a boost converter, which boosts the voltage up. Ideally, it'd probably be best to have both. You can actually find buck boost converters that do both, so you can step this up to, let's say, 30 volts if you want. But of course, anytime you step up or step down, there's heat dissipated. You can see there is a little heat sink on here, but definitely far less heat is dissipated out of a system like this than it would be out of a regulator or a potentiometer, where you're doing it like a linear kind of supply. It may seem counterintuitive to have a switch mode power supply operating off a switch mode power supply, but I can assure you this is actually a pretty good way to do this. I use this thing a lot. In fact, I'll put a link in the description below for the site I got this from. It was eBay. It's made by a company called Minghe, actually it's called. They make a variety of these different devices, but if you do want to get other voltages out of this, I do find that's a better way to do it, just in my opinion. The other thing you can do, I'll mention this while I have this all out. Let me just unplug this other power supply here. The other thing you can do is you can actually get different voltages just by tapping off of these here. And you're doing that, best way to explain that, you're doing that by a voltage differential. Real quick, I'll just move these out of the way so we can access 12 volts. Now again, red is 12 volt positive. This one over here is 12 volt negative. Now you see, if we hook those up, they do coincide with each other, which is perfect. And if I switch this over to here, you can see we get that negative voltage. And if you take these two and actually instead you put the ground wire over to the positive here, you can see we actually get negative 23 volts, because the difference between positive 12 and negative 12 would obviously be 24. You can actually switch these around if you wanted to get positive voltage out of it and use the negative as your ground source. So you can see we have negative 23, almost negative 24 volts. The catch to this is you can only get so much amperage out of this. You can see the 12 volt rail is only, the negative 12 volt rail is only rated for 1 amp, whereas the positive rail is rated for 10 amps. So you're not going to get 10 amps at 23 volts. That's the one drawback. If that was the case, then what I would have done is I would have took my little buck converter here, and I would have connected that between the negative and the positive 12 volts, so I could have gone up to 24 volts on that. And that is still a possibility, but like I said, you're not going to get a lot of current out of it. You can do the same thing between any of these. If you wanted to get 7 volts, I believe, you can go between the 5 volt and the negative 3 volts, or positive 3 volt. Let's see. Well, anyway, you get the 5 volt, the 3 volt, you can get 1.8. If you go over here between 5 and, yeah, there you go, there's your 6. So it depends on where you tap, depending on how much voltage you can get out of this thing. So that's definitely something to keep in mind. But always, it's going to depend on how much current. Now, between a 10 amp and a 22 amp line, I think you're going to get the 10 amps. So that's not bad if you want a 6 volt tap off of that. The last thing I can mention, and this isn't something I've actually done myself, but I have seen other videos do it, you can actually take 2 of these power supplies and combine the power out of them to get 24 volts. And I think they use one power supply as the negative supply and they use the other one as the positive. But that's not something I've experimented with. Maybe I'll do that in a future video if I decide to do so. I have come across videos of people who have done that, and it seems like it works, but it's not something I need in my particular situation, so it's not something I've explored. Anyway, guys, I want to thank you for watching this particular video. I hope you found it useful. If you still have questions about this particular build, please feel free to ask me. I'm pretty much always here to help you guys. I don't have a cutoff where I say, well, I posted that last month, I'm not going to make respond to comments on it. That's not me. I find that I like the interaction with your people, the questions you ask me, even suggestions like, hey, try this next time instead of that. Like all that stuff is very, very helpful for me and the rest of the community as a whole. And if you're not already a subscriber to this channel, I really would appreciate if you do subscribe. You can click up here, my little logo, and to do so. You may also see at the bottom of the screen here, there's a couple other videos you can check on. And we'll see you guys next video. Thank you for watching as always.